Hey guys, it's Miss Delcambre. Today is Wednesday, September 9th. The items that you'll need will be your journal, glue, pencil, highlighter, and your notes for 1.2 and 1.3. Okay, so today we're going to be going over our notes. We have our absolute value video with Swoop, and you will also show a video on comparing and ordering integers. So let's get started. Okay, so I'm going to pull up my document camera. Here we go. So today's 9-2. We're going to start with comparing and ordering integers. And then on the next page, this is also 9-9-2020. And you will be doing finding absolute value on this page. So let's go ahead and start. When we're ordering positive and negative integers, integers are positive whole numbers and their opposites, which would be their negative counterparts. And when we order them, it's really good to put them on a number line. And this is an integer number line.
All remaining parent pickup children may go out.
You will notice that this integer number line has all positive numbers, positive whole numbers, negative whole numbers, and zero. There's not a fraction or a decimal on here. So we know that this is an integer number line. So when you read a number in a number line from left to right, the numbers are in order from least to greatest. I'm going to give you a little clue to help you remember when you read them in which direction you're going to go. So if you look closely, left starts with L, least starts with L. Right has an R in it, greatest has an R in it. So if you're going to read from least to greatest, you're going to read from left to right. Now, the opposite happens. So if you're going to read from greatest to least, excuse me, okay, R to L, you're going to read from right to left. You see how there's an R in greatest and an R in right, an L in least, and an L in left. So that's a little key tidbit that we can take away from when we are ordering integers, ordering rational numbers, ordering numbers in general. All right. So graph the values of in each table on the number line. Then list the numbers in order from greatest to least. All right, so we've got change in stock prices. So you have 6 numbers. We have our number line here. We're going to place them here on our number line. So we start off with -5. -5 is located to the left of 0 between -4 and -6. And I'm just going to put a dot on my number line where it's located at. +4. It's going to be to the right of 0, and it's going to be between 3 and 5. I'm going to put my dot there. We have 0, and 0 is located in the middle. Remember, 0 is neither positive nor negative, and it splits the number line into a positive side and a negative side. Next number is -3, and -3 is right here between -2 and -4 to the left of 0. We have -6, which is to the left of 0 between -5 and -6. And then we have +2, which is on the right side of 0 between the 1 and the 3. So we're rewriting them from greatest to least. Guys, it's very important for us to remember how they want it done. I would make sure that every time you have a problem that says graph or put in order from least to greatest or greatest to least, that you highlight that, star it, so you can go back and remember it. So greatest to least, so greatest are, I gotta go from my right and read it to my left. So if I start at my right, the furthest one that I come to is 4. So 4 is the greatest number. And then 2. And then 0. And I have -3. I have -5. And I have -6. All right. The farther I get to the left of 0, the smaller my numbers get. Okay, the further I get away from 0 to the left with the negatives, the further it is away from 0, negative number is away from 0, the smaller it is. The closer a negative number is to 0, it's greater. Okay, so that's a little key tidbit that we're going to write down in a bit down here after this. So writing inequalities. Now you've probably seen these inequality symbols when you were young. Your kindergarten or first grade teacher started talking about like the alligator mouth. Well, it's not an alligator mouth. It's called an inequality symbol. And an inequality is a statement in which two quantities are not true. They're not true or not equal. The symbols, here are the two symbols that we use to write inequalities. And if you're looking on a computer, these symbols are located where the period and comma are. So you would do shift period and shift comma to get these two symbols. So this symbol right here means less than. Okay, and I think of this as a lazy L that fell over. Because if you straightened it up a little bit, it becomes an L. And this then is greater than. And if you think back into your kindergarten and first grade years, the mouth is open, so it's greater. And also another thing that we've noticed is that if I write a G, do you notice my part here that makes the G looks like that inequality symbol? So the inequality symbols kind of match up. So that's how, another reason that you can remember that that's greater than. All right, I'm going to show you a trick on how we can do this. So if we compare these two numbers, and we're going to use our inequality symbols. So I'm going to use a number line. So I have -10 and -2. Well, remember what I said. The closer the negative number is to 0, the greater it is. So -2 would be greater. So I'm going to put 2 dots there and 1 dot there. And then if I connect the dots like this, it makes my inequality symbol. So -10 is less than -2. Okay, I'm going to go up here. Well, no matter what, a positive number will always, always, and forever be bigger than a negative. So 6 is always going to be bigger than -6. So -6 would be less than 6. And here we have -7 and -8. So I'm going to look up here. All right, they're right next to each other, but -7 is closer to that 0 than -8 is. So -7 would be greater than -8. So a little key thing to remember when inequalities, the point or the tip or the end goes to the smallest number. Smallest number. And the mouth is open to the larger number or the biggest number. And I'm going to put biggest number. And that little thing that we were talking about with negatives, so when we compare negatives, when we're comparing negatives, the closer a negative number is to 0, it's bigger. Closer a negative number is to 0, it's bigger. And the further, or the farther, however you want to say it, I say further. This is why I teach math and not English, because I can never differentiate between the two. The further a negative number is to 0, it's smaller. Okay? Now, we're going to watch a Mr. Burger video real quick. It should take about a minute. Give me one moment. Let me minimize this and pull up our Dr. Burger video. Ooh, wrong thing.
to see this ordering of integers happen before our own eyes, let's take a look at an example. So here I have three integers, 5, -3, and 2, and I'd like to order them from the smallest up to the largest. So we might have to actually rearrange these things, and so actually I'm going to, right now, allow us to move around by using the cutting property of mathematics. That's just a joke. There's no cutting property of mathematics. But there's a cutting property of scissors, and you should never run with them. Okay, so here we go. Now, how would you order them? Well, I'm just going to put these numbers on the number line and see where we go. So 5 is way off to the right. That means that's pretty big. 2 is a little bit to the right, but not as far to the right, so it's smaller than 5. And -3 is way off to the left. And so therefore, when I see this, this automatically gives me the ordering. -3 is the smallest of the three numbers. 2 is in between. And 5 is the largest. So the ordering from smallest to largest is -3 to 5. And we can see that by seeing their locations on the number line and reading from left to right. Let's try one more. So here we've got a bunch of them. -1, 1, -4, and 0. So I use the cutting property. Aren't numbers a real cut up? Okay, so now we have the numbers. And now let's put them on the number line. So let's see. So -1 is just a little bit to the left of 0. 1 is a little to the right of 0. -4 is way off to the left. And 0 goes right in between. All right, well, now that we have this ordering, this actually tells us smallest to largest. -4 is the smallest, moving from left to right. Then we get to -1. Then we get to 0, and then we get to 1. So the ordering from smallest to largest is -4, -1, 0, and finally 1 is the biggest. Very cool. That's the power of ordering using a number line.
All righty, guys. So that sums up our comparing and ordering integers. Now we're going into finding absolute value, which is the most easiest thing in the world. And now we're going to watch one of my favorite videos, a la Schmoop. And it tells you just a little intro, about 2.5 minutes of absolute value. And I hope you like this as much as I do.
Absolute value, a la Schmoop. A healthy sense of optimism can have a strong effect on one's psyche. Psyche. For example, you might hear an optimistic person say, "I just got a terrible haircut, but my new faux hawk will make me stand out from the crowd." Or, "An earthquake just swallowed my home, but I get to be on the news." Or, "An asteroid the size of the sun is hurtling toward Earth, and we have only a few minutes left to live, but at least we're all going together." See how much nicer things seem when we put a positive spin on them? Then you're just going to love absolute value. All this guy does is take negatives and turn them into positives. Of course, he also takes positives and then keeps them positive. We're talking a lot of positivity. Absolute value determines how many spots away a number is from 0 on the number line. You could never be a negative number of spots away from 0, which is why absolute value is always so dang positive. You can tell you're dealing with an absolute value because you'll see a number surrounded by bars on either side. It looks almost like they're in prison, or as absolute value would say, on vacation. Take any number, put it through the absolute value machine, and you'll get its true colors. Say you want to find the absolute value of the number 7. First we put it in prison, so we know we're looking for the absolute value, and not just looking at a run-of-the-mill 7. Then we can count the spaces between 0 and 7, which, surprise, surprise, is 7. It will be the same story for every single positive number, which makes our job easier. However, it's a bit different when we have a negative number. Suppose we want to find the absolute value of -3. First, we jail that sucker. Then we locate it on the number line. We count 3 spaces in between -3 and 0. So our absolute value is 3. But what if we have a number with more than one negative sign? Suppose it's been hoarding them since 1973 and has accumulated 300 of them. Doesn't matter. No matter how many times you reflect the number 3 across 0, it will always be exactly 3 spaces away from 0. Therefore, its absolute value will always be 3. Being so positive all the time can definitely lift your mood and keep you from being down in the dumps. Absolute value is about as upbeat as they come, which can actually be really annoying at times. If you tell anyone else, we'll deny it, but boy, we hate that guy.
All right, and that was
Absolute value, kalashma. A healthy
hold
sense.
on. That was one of my favorite little schmoop videos. All right, so absolute value is super easy, guys, because absolute value just talks about the number's distance away from 0 on a number line, and distance always is non-negative. It's just basically counting. That's all it is. So it's always going to be it's never going to be a positive. It's never going to be a negative. It's a non-negative. So it's just going to be that number without a negative sign because we're counting. So like from -3, what's the absolute value? -3. Well, we count 1, 2, 3. Well, it's 3 units. So its absolute value would be 3. So I have the absolute value of 26. That would be 26. It's 26 spaces away from 0. The absolute value of 12 is 12. It's 12 spaces away from 0 on a number line. Absolute value of -39, you guessed it, is 39. 39 spaces away from 0 on a number line. -7 would be 7. Absolute value of 43 would be 43. Absolute value of 17 would be 17. And so forth. That would be 30. Absolute value of 29 is 29. Absolute value of 28 is 28. Absolute value of 31 is 31. So the key thing with absolute value, guys, is remember that it's the distance, keyword distance, away from 0 on a number line. Now, sometimes we're just going to do this on some stickies. They may put an operation going on inside absolute values, like the little brackets. So say 6 plus 4. Let's say absolute value is 6 plus 4. So it's just like take those into consideration like they're parentheses. So 6 plus 4 gives me 10. Absolute value of 10 is 10. That would be my answer. All right. Say if it's a subtraction problem. Or absolute value of 5 minus 2. Well, I'm going to solve this. 5 minus 2 gives me 3. The absolute value of 3 is 3. Now, what if they throw a multiplication problem in there with absolute value? Can you do it? Yes, you can. The absolute value of 5 times a -2. Well, 5 times -2 gives me a -10. We've been doing those on our builder. The absolute value of a -10 is 10. So even if you solve it and your answer is a negative, remember it's a distance away from 0, so it will always be just that number. Okay, it would just be 10 because we're talking about distance away from 0. It's non-negative. All right, guys, your homework is 2 worksheets, 1.2, which you're comparing and ordering integers. And then you have 1.3, which you are writing down the absolute value and solving for those questions. All right. So tomorrow we have our 2.1, which we start into rational numbers. So all those decimals and fractions we've been talking about are lumped into rational numbers. And then Friday is our BOY math test, our beginning of the year math review. So get ready for that. More to come. Bye.